We're going to look at the time value of money as it applies to annuities. We're going to consider the future value and the present value of an annuity, and we're also going to look briefly at amortization tables. A series of identical periodic cash flows at the end of each period of time is referred to as an annuity. For instance, $100 at the end of year 1, $100 at the end of year 2, year 3, year 4, year 5, and year 6, and so on. That would be referred to as an annuity. Examples of annuities include payments on car loans, where you have an equal payment every month. Payments on home mortgage loans, again, an equal payment every month. Lottery payouts. For instance, let's say you win the $1 million lottery. You don't get $1 million today. You can elect to receive $50,000 a year for 20 years, or you can receive a smaller lump sum payout, say $600,000 or $700,000. That would be the present value of the annuity. Also, we consider retirement saving plans, where we set aside an equal amount from each paycheck. That would be considered an annuity. There are two types of annuities: ordinary annuities, in which the cash flows occur at the end of each period of time. That's going to be our primary focus. And then also an annuity due, in which the cash flows occur at the beginning of each period. We could consider three ways to calculate the future value of an annuity. First, a mathematical formula. Second, a financial calculator. Or third, future value factor tables. Here's the formula for the future value of annuity, where C is the periodic cash flow or payment. N, again, is the number of periods. And R is our periodic interest rate. Remember, if we're talking about numbers of years, our interest rate will be expressed as an annual interest rate. If we're talking about number of months, then the interest rate would be a monthly interest rate. I will leave it to you to solve problems using the mathematical formulas for calculating the future values and present values of annuities. One of the Excel assignments that you may need to work will require you to do that. Let's go ahead and consider a financial calculator valuation of a future value of annuity. We're going to use the payment field now to enter the series of cash flows, or the annuity payment. Let's begin by considering an annuity with a $1 periodic payment and a 10% interest rate. If it's a one-year annuity, in other words, we put $1 in the bank at the end of the first year, obviously it doesn't have a chance to compound at all, and the future value of that annuity will simply be $1. If we extend our annuity to 2 periods, notice the first year's annuity contribution has a chance to compound for 1 year and will grow to $1.10. The second year's contribution doesn't have a chance to compound and will only be worth $1. So the total future value of our annuity will be $2.10. For a 3-year annuity, we would make a third payment in the third year. Now notice the payment we made in the first year has 2 periods to compound, and it will grow to $1.21. The cash flow we deposit at the end of year 2 will only compound for 1 period and will grow to $1.10, while the payment we put in at the end of year 3 doesn't compound at all and will only be worth $1. When we sum up the total future value, we have $3.31. Now notice, in our financial calculator, to solve for this future value of annuity, we would set N to the number of periods to 3, our 10% interest rate, 0 for our present value, unless we have any initial amount in the account. Of course, the present value is 0. Our payment would be the $1 annuity, and we can then solve for the future value, and we get $3.31. As with lump sum amounts, we can consider this future value when we have a $1 annuity payment to be what we refer to as our future value of an annuity factor for 3 years and 10%. If we were to increase the number of years to 4, it would be our 4-year present future value annuity factor. And again, 10% and 4 years. And again, notice our future value factor would be $4.641. Let's go ahead and look at a future value factor table for an annuity. Once again, we go to our future value annuity factor table. We highlight the column for our 10% interest rate and 4 years. and the two factors intersect at a value of 4.641, which was the future value interest factor for an annuity that we found using our financial calculator when we had our payment entered as $1. So again, we can also calculate future values of annuities with our future value annuity interest factor table. Let's take a look at how we would do that. So our future value will equal our payment times whatever our future value interest factor for annuity is. And in this case, we had a factor at 10% interest in 4 years. And let's go ahead and consider what the future value would be if our payment was $100. Well, our factor was 4.6410, so we would multiply that by the $100, and we would find the future value of the annuity is $464.10. Going back to our Excel worksheet, we can see that if we change the annual payment to $100, certainly the future value is our $464. Let's consider some problems that might require us to solve for the future value of an annuity. Let's say we plan to retire in 4 years and have a retirement goal of $1 million. How much would we need to set aside every year if we can earn 5%, 10%, and 12%? Let's begin with the 5% interest rate. Since our goal is to have $1 million, we will put that in as our future value in our financial calculator. Enter it as a negative amount so you can get a positive amount for your payment. We have 40 years to retirement, so 40 for the number of periods. 5 for our interest rate. If we have no money set aside now for retirement, we would need to then solve for our payment and find that we would need to set aside $8,278 every year for the next 40 years if we wanted it to grow to $1 million by the time we retire. If we could earn a 10% interest rate, we're going to find we don't need to set aside as much. Again, $1 million is the future value. That's our goal. We have 40 years, a 10% interest rate. We have no money in our account to begin with, and we can see the payment would need to be $2,259 is what we would have to set aside at the end of every year for the next 40 years to reach our goal. If we could earn a higher interest rate, 12%, not to be surprised, we would have to set aside less money. We've got the $1 million future value, 40 years, a 12% interest rate, 0 for the present value, and we would only need to set aside $1,303. So one thing you can see, it's important to earn a decent amount of return on your retirement savings. If you put your money aside in a passbook savings account and earn a low rate of interest, it's unlikely you will achieve your retirement goals. Let's consider another situation. What if you earn 10% but wait 10 years so that you only have 30 years until retirement? How much would we need to set aside in each one of those years? Again, our goal is to have $1 million at retirement. But now, since we wait 10 years, we only have 30 years for an annuity. We have our 10% interest rate, again, starting with 0 today. And we can see we would need to set aside, instead of $2,259, we would need to set aside over $15,000 every year for 30 years to reach our goal. This emphasizes why it's so important to start saving early when you plan for retirement. Don't wait until you're 30 or 40. As soon as you're out of school and begin to save, start setting aside money, because the amount you need to set aside is much smaller. Let's consider another scenario. Say you wait an additional 5 years until you retire. That is, you make this $2,259 a year payment, but you wait 5 more years, so you have a total of 45 years until you retire. How much will you have? Well, there's our payment, our $2,259. Now we're going to have a 45-year annuity, again at our same 10% interest. We have no money in the account today, and we would see it would grow to $1,624,301, an extra $624,000 just by waiting an additional 5 years until we retire. Let's consider a problem where we have an annuity and also an initial amount. Let's say we plan to retire in 40 years and we have a retirement goal of $2 million. If we have $5,000 today and can earn 12% interest, how much do we need to set aside every year? So again, our goal is to have $2 million, so that's our future value. We've got $5,000 today, so that's a present value. Notice the sign on the 2 million is a negative and the sign on the 5,000 is a positive because we hope to take the 2 million out, and yet we've put in the 5,000 today. We're going to have our money compounding for 40 years. We're going to make 40 annuity contributions at a 12% interest rate. Finally, we can solve for the payment, and we find we would need to contribute $2,073 every month or every year to reach our goal of $2 million. If we didn't have the initial $5,000 to deposit today, we would have to make larger contributions every year for the next 40 years. The contribution would increase from $2,000 a year to $2,607 per year. Let's go ahead and see how we would solve for the number of periods and interest rates for future value of annuities. If we have $1,000 a year to invest at 10% interest, how many years will it take to have a future value of $100,000? Let's go ahead and begin by putting in our future value. We'll enter the future value as a negative $100,000 because again, we're going to want to take that amount out of our account. We're going to contribute $1,000 per year, so that's our payment. We don't have any money in the account today, so we'll put 0 for the present value. We have a 10% interest rate, and then finally we can solve for the number of periods, and we find it would take 25.16 years if we invested $1,000 a year at 10% interest to have our account grow to $100,000. Again, the important thing is to watch the signs on these things. Cash flows going in versus cash flows coming out. Let's consider another problem. What interest rate would you need to earn in order for a $1,000 annual investment to grow to $100,000 in 20 years? Again, our future value, the amount we'll take out, will enter as a negative $100,000 in our financial calculator. We have an annual contribution or payment, our annuity, of $1,000 a year. We have nothing in the account today, and we're going to be making this annual contribution at the end of each year for the next 20 years. Finally, solving for our interest rate, we see we need to earn 14.80% annual interest. How would that answer change if we had $5,000 saved or in the account today? Obviously, it wouldn't take quite as high a rate of return. Let's go ahead and assume we want to have, again, $1 million in 20 years if we've got $5,000 saved today and we're going to make an annual payment of $1,000. Well, once again, the future value will be entered as a negative $100,000 because it's an amount we want to take out. We're going to make an annual payment or put in $1,000, so that will be positive. The $5,000 we're putting in today also will be a positive amount. We've got 20 years for our annuity, and let's finally solve then for the interest rate. With an initial contribution of $5,000, we would only need to earn a 10.68% annual rate of return compared to the 14.8% annual rate of return we would need to earn if we didn't have that $5,000 contribution today. So again, we can calculate future values of annuities using our mathematical formulas, where C is our periodic cash flow, N is the number of periods, and R is our periodic interest rate. We can use our financial calculator, where the payment field is our annuity payment, or we can use our future value factor tables. Where to find the future value, we take the annuity payment and multiply it by a future value interest factor of an annuity at, say, 10% and 4 years, which we saw was 4.641. Whatever we have for our payment, we multiply it by that factor and solve for the future value.